Now, let's study chemical properties of alkenes. Learning outcomes. At the end of this topic, we should be able to describe the combustion of alkene in excess oxygen and limited oxygen. And for E, we should know how to explain the halogenation reaction of alkenes. Chemical properties of alkenes. Combustion of alkenes in excess oxygen and in limited oxygen. For halogenation, types of reaction is free radical substitution. Reagent we use is bromine or chlorine. Condition under UV light or HU. Product form is haloalkane. Combustion in excess oxygen. Alkane burn in oxygen to give carbon dioxide and water. For combustion in limited oxygen, it will produce carbon monoxide and H2O. While combustion in very limited oxygen, the product is only carbon or soot and H2O. Halogenation. Types of reaction is free radical substitution. Name of reaction is halogenation. Look at the general equation. So, alkane react with X2 or halogen. In presence of UV, it will produce haloalkane and hydrogen halide. For example, methane react with chlorine to produce chloromethane and hydrogen chloride in the presence of UV. Example number 2, ethane react with bromine to produce bromoethane and hydrogen bromide in the presence of UV. Example 1 and 2 give only one haloalkane product only, since the alkane contain identical hydrogen atoms. For example 3, we have two haloalkane as product because alkane contains non-identical hydrogen atoms. So, we have minor and major product. The major product formed due to the stability of free radical. Secondary free radical is more stable than primary free radical. This slide shows the differences when propane react with chlorine and bromine. Reaction with chlorine will produce two products because it fast and unselective, while reaction with bromine, it will form only one product because it slow and selective. Now, let's study 5.2 alkenes. This is overview for 5.2 alkenes. Learning outcome. At the end of this topic, we should be able to draw structures and name alkenes according to the IUPAC nomenclature for side chain and branch alkene. Parent change equal or less than carbon 10. Cyclialkene, number of carbon 3 till carbon 6, and simple diene carbon 4 till carbon 6. Alkenes. The general formula for alkenes is CnH2n, where n equal or larger than 2. The functional group for alkenes is carbon-carbon double bond. In carbon-carbon double bond, we have one sigma bond and one pi bond. Restricted rotation of carbon-carbon double bonds causes cis-trans isomerism. For cycloalkene, general formula is CnH2n minus 2, isomeric to alkyne CnH2n minus 2. IUPAC nomenclature. Step number 1. Determine the parent name by selecting the longest chain that contains the double bond and change the ending N in alkane to ene, E-N-E. Step number 2. When the chain contains more than 3 carbon atoms, numbering is needed to indicate the location of the double bond. For example, we choose the name for the compound is 3-octene, not 5-octene, because to indicate the location of the double bond, we should choose the lower number. Step number 3. Indicate the position of the substituent by the number of the carbon atoms to which they are attached. The name is 2-methyl-2-butene, not 3-methyl-2-butene. Step number 4. If the alkene contains more than one double bond, change the ending "ene" to diene if there are 2 double bonds, triene if there are 3 double bonds. Example, so the name is 1,3-butadiene, not 1,3-dibutene. Example number 2. So the name is 1,3,5-heptatriene, not 1,3,5-triheptene. Step number 5. In cycloalkenes, number the carbon atoms with a double bond as 1 and 2 in the direction that give the substituent accounted first with a small number. Example, so the name is 1-methylcyclopentene, not 2-methylcyclopentene. Example number 2. What is the name of the compound? So the name of the compound is 3,5-dimethylcyclohexene, not 4,6-dimethylcyclohexene. We still choose the lower number. Step number 6. When alkyl groups are performed as a substituents, it is known as alkene, loss of hydrogen become alkyne. Another example is vinyl groups and allyl group. Step number 7. Prefix cis and trans are used if the alkene shows geometrical isomerism. Example, for this one is cis-2-pentene, and for that one is trans-2-pentene. Prefix cis and trans also are used if the cycloalkane shows geometrical isomerism. Chemical properties of alkenes. This is an overview for chemical properties of alkenes. We have one electrophilic addition and second oxidation. Learning outcomes. At the end of this topic, we should be able to explain the addition reaction alkenes with hydrogen in the presence of catalyst. Second, halogen in inert solvent. Reaction alkene with halogen in water. Hydrogen halide. And the last is acidified water. For H, we should know how to predict the product's form according to the Markovnikov rules. Electrophilic addition. Catalytic hydrogenation. Example, alkene react with hydrogen in the presence of catalyst. The product form is alkene. Halogenation in inert solvent. So, the reagent is halogen in inert solvent CH2Cl2. Product form is vicinal dihalide. When the alkene react with bromine in inert solvent, the observation is reddish-brown color of bromine decolorized. The name of chemical test is bromine test. Halogenation in water. Reagent X2 and water. X2 can be either chlorine or bromine. The product form is halohydrine. Example, for this reaction, it must follow Markovnikov rules. Halogen will attach to the carbon with greater number of hydrogen atoms, while OH will attach to the carbon with fewer number of hydrogen atoms. What is Markovnikov's rule? Markovnikov's rule states that in the electrophilic addition of alkenes, the electrophile adds to the carbon atom of the carbon-carbon double bond with greater number of hydrogen atoms. Example, when the two equations below are tested with bromine in water. Name of chemical test. Bromine test. The observation is reddish-brown color of bromine decolorized. Next, we go to hydrohalogenation. The reagent is hydrogen halide, HX, where X it can be chlorine or bromine. The product form is haloalkane. Reactivity HCl is less reactivity than HBr. Example 2. The addition of hydrogen bromide to an unsymmetrical alkenes, it must follow Markovnikov rule. Hydrogen atom adds to the carbon atoms of the double bond that already has greater number of hydrogen atoms, while halogen atom adds to the carbon atom of the double bond that has the fewer number of hydrogen atoms. So, the product can be classified as a major product. Anti-Markovnikov rules. In the presence of peroxide, such as ROOR or H2O2, the addition occurs in an anti-Markovnikov rules. Example, when alkenes are treated with HBr in the presence of peroxide H2O2, the addition occurs in an anti-Markovnikov rules. The hydrogen atom of HBr attached to the doubly bonded carbon with fewer of hydrogen atoms, so it can form major product. For this reaction, it's only occurred in the addition of HBr to an alkene. Acidified water. The acid catalyzed addition of water to the double bond of an alkene or hydration of an alkene is a method for the preparation of low molecular weight alcohols. The acid most commonly used to catalyze the hydration of alkenes are dilute solution of sulfuric acid and phosphoric acid. The addition of water to the double bond follows Markovnikov rules. The product form is alcohol. Example 1. Alkene react with water in dilute H2SO4 form alcohol. Example 2. The major product form when the reaction follow Markovnikov rules. Summary chemical reactions of alkenes. Please do by your own using the suitable alkenes. That's all. Bye-bye.